All right, welcome to The Explainer. Today, we are cracking open the biggest case file you could possibly imagine, the universe itself. And our lead detective, our guide through this whole cosmic mystery, well, it's none other than the brilliant Stephen Hawking. For as long as we've been, well, us, this one single question has been the driving force behind everything. It's made us look up at the night sky and just wonder. It really is the fundamental mystery we've all been trying to solve.
Okay, so where do we even start with a case this big? Well, let's go right back to the beginning, to the original crime scene, you could say. And we'll look at our first picture of the universe, which, as you'll see, was way, way off.
For literally centuries, the whole investigation was just stuck. It was stalled. And it was all because of this one really simple but incredibly powerful idea that we were the center of it all, that everything, the sun, the planets, all the stars, that it all revolved around us. But then our detective tools started getting better, right? Our telescopes got more powerful, our theories got smarter, and suddenly the evidence was just undeniable. Turns out we weren't the center of anything. In fact, we were just this tiny little speck in a huge, dynamic, and ever-changing cosmos.
And that's when the first huge break in the case happened. I'm talking about a clue so big it didn't just change the investigation, it completely tore up our old map of reality. It gave us a totally new way of seeing, well, everything.
Okay, so check this out. The leap from Isaac Newton to Albert Einstein, it changed the game. Newton saw space as this fixed, unmoving stage and time as this universal clock that just ticked away for everyone, everywhere, separate things. But Einstein, he came along and showed that, no, they're actually woven together. They're part of the same dynamic fabric.
The best way to picture it is like this. Imagine a giant trampoline. Now, you put a heavy bowling ball. That's our sun right in the middle. What happens? It creates a big curve, a big dip in the fabric, right? Well, that's what massive objects do to space-time. And a planet like Earth, it's not being pulled by the sun, it's just rolling along the edge of that curve. And that, my friends, is gravity. So just when we're trying to get our heads around this whole space-time thing, boom, another bombshell. It's 1929, and this cosmic detective named Edwin Hubble points his telescope up, and he sees something incredible. The galaxies, they weren't just hanging out. They were all flying away from us. The whole universe was getting bigger. It was expanding. Now, that discovery leads to a pretty mind-blowing conclusion, right? If the universe is expanding today, what happens if we hit rewind on the cosmic movie? Everything that's flying apart now must rush back together, all of it, converging on one single unbelievably hot, unbelievably dense point way back in the past. And that idea, well, that became our leading theory for how the entire universe began. We call it the Big Bang, but it's not what you think. It wasn't an explosion in space, it was the explosion of space and time itself. This was the very first moment of our cosmic story.
All right, so the big picture is starting to come together. But just when we thought we were getting somewhere, the clues from the tiny world, the subatomic, quantum world, showed up and made the whole case a whole lot weirder. Okay, get ready for this, because this idea is a real head-scratcher. It's called the uncertainty principle, and what it means is that on the smallest possible scale, the universe is fundamentally fuzzy. It's not perfectly predictable. You can know exactly where a tiny particle is, or you can know exactly how fast it's going, but you can never, ever know both at the same time. There's a built-in limit to what we can know.
And this quantum weirdness, it gets turned up to 11 when we look at one of the most mysterious, most extreme objects in the whole universe, a black hole. These things are born from the spectacular death of a massive star, when it runs out of fuel and just collapses under its own incredible weight, crushing itself down into a single point of infinite density.
And for the longest time, we basically saw them as cosmic vacuum cleaners, one-way trips to nowhere. If anything crossed that point of no return, the event horizon, it was just gone, forever. Light, matter, information, poof, wiped from the universe. But then, Stephen Hawking enters the scene and delivers what might be the biggest plot twist in the entire story. He did something absolutely brilliant. He took Einstein's big ideas about gravity and smashed them together with those strange, fuzzy rules from the quantum world. And what he found changed everything we thought we knew.
His idea was absolutely revolutionary. He realized that because of all that quantum weirdness happening right at the edge of a black hole, they're not completely black after all. They actually glow, just a tiny, tiny bit. They leak a faint radiation back out into space, something we now call, you guessed it, Hawking radiation. And this means they're not eternal prisons. They can actually evaporate, and they have a life and eventually an end.
So let's recap the evidence. We've got the Big Bang, an expanding universe, and black holes that aren't so black after all. With these major clues on the table, we can finally turn to the last chapter in our case file. So where is this all going? What's the end of the story? And honestly, this is one of the biggest unsolved mysteries left. Are we heading for a big freeze, where the universe just keeps expanding forever until it's cold, dark, and empty? Or is there a big crunch in our future, where gravity finally wins, pulls everything back together, and ends it all in a fiery collapse? The jury's still out on that one.
And what about time itself? I mean, why does it only seem to go one way? Why do we remember yesterday but not tomorrow? Well, Hawking pointed out that there are actually 3 arrows of time, and they all point in the same direction. There's the thermodynamic arrow. Things get more chaotic, not less. A broken egg never unscrambles. Then there's the cosmological arrow. The universe is expanding, not shrinking. And finally, the psychological arrow. We remember the past. All 3 are locked together, and that's why time flows forward.
For Hawking, all these clues were pointing toward one thing: the holy grail of physics, a single, complete, unified theory, a theory of everything. He believed that if we could just find that one set of rules that governs everything from the Big Bang down to the tiniest quantum particles, we would, in a way, understand the grand design of it all.
But in the end, maybe the biggest takeaway from Hawking's work, from his whole life, is this. The real triumph isn't just about finding the final answer. It's about the quest itself. It's about that relentless, unending human curiosity that makes us look up at the stars and ask, why?
And that's such an incredible thought to end on, isn't it? That no matter what our physical limits might be, the human mind, that's our real spaceship. It's free to travel across the entire universe, to journey back to the beginning of time, and to unlock its deepest secrets. The story is far from over, so I guess the only question left to ask is, what are we going to discover next?